Okay, so in example number 1, we see a polynomial with 4 terms: x cubed, 2x squared, 36x, and 72. Let's see if we're able to factor this by GCF. I have an x cubed in the first term, I have an x squared in the second term, I have an x in the third term, and I have no x's in my fourth term, meaning that the variable x is not part of the GCF. Continuing on and looking at the coefficients and the constant value, I have 1 x cubed, 2, 36, and 72. Well, in all 4 of the numbers that I have, the greatest factor would just be the number 1, but there wouldn't be any point of just factoring out the number 1. So it looks like there is no GCF that exists for this polynomial that I have. So instead of factoring it by GCF, I'm going to try factoring it by grouping. Am I able to group the 4 terms that I have into smaller groups? So taking maybe the first 2 terms together and looking at the second 2 terms together. So in just the first 2 terms, I see that I have an x cubed and I also have an x squared, meaning that x squared exists in both of my terms. So I'm actually going to rewrite this out separately. I have, again, I grouped my terms together, x cubed plus 2x squared, and I see that there is an x squared that is the greatest common factor in my first term. So these are both divisible by x squared. So if I factor out an x squared from this term here, I have x squared times x cubed divided by x squared is just x, and x squared, or 2x squared divided by x squared is positive 2. Okay, so that was my first group, x cubed plus 2x squared, and now I'm going to look at my second group. I have, one second, I have 36x plus 72. So 36x plus 72, seeing what is my greatest common factor in this grouping. Well, I have an x in the first term, and I don't have an x in my second term, so I can't factor out an x. However, looking at the number 36 and 72, the greatest common factor, what is a factor of both of those numbers, they are both divisible by 36, meaning that 36 is the greatest factor that they have in common. So if I factor out a 36 from both of those terms, 36x divided by 36 equals x, 72 divided by 36 equals positive 2. So again, what I did was I took my polynomial, which originally had 4 terms, I broke them up into 2 separate groups. I grouped the first 2 terms together, I grouped the second 2 terms together. So technically what I end up with is, in my first term, I have this x squared times x plus 2, and my second term was the positive 36 times x plus 2. So in my first group and in my second group, now what I can do is factor by factoring out the greatest common factor. Both of those terms have an x plus 2 in common, so I'm going to factor out the x plus 2 from both of those terms. And when I factor out an x plus 2, x squared times x plus 2 divided by the x plus 2 equals x squared. And in my second term, 36 times x plus 2 divided by x plus 2 equals positive 36. And lastly, checking to make sure that I did this correctly. I know this is going to take a little bit of time, but we always want to make sure that we factored it correctly. So I want to make sure that when I distribute this and kind of factor out all the numbers again, that it does match the original polynomial that I started with. So factoring this, I am going to use the distributive property. I'm going to take x times x squared, x times 36, 2 times x squared, 2 times 36, and I end up getting x cubed plus 36x plus 2x squared plus 72. I want to check to see that all of the terms in that polynomial do match the original polynomial that I had. Even though it's in a slightly different order, all the terms are exactly the same, meaning that this does check out, that our factored form here, x plus 2 times x squared plus 36, is the correct factored form of our original polynomial.